Hey space explorers, and welcome back to the channel. Today, we're venturing out to the far reaches of our solar system, to the realm of the gas giants, to visit a moon that's more like a planet. Get ready, because we're diving deep into the mysteries of Jupiter's largest moon, Ganymede. Now, you might have heard of Ganymede. It's the biggest moon in our entire solar system, even larger than the planet Mercury. It's a world of ice and rock, a celestial giant orbiting the even more colossal Jupiter. But Ganymede holds a truly unique and baffling secret, something no other moon can claim. It has its own magnetic field. Think about that for a second. We know planets like Earth have magnetic fields. Ours is what protects us from solar wind, gives us the beautiful auroras, and makes our compasses point north. It's generated by the churning molten iron core deep within our planet. But for a moon to have one, that's completely unheard of, except for Ganymede. This discovery, made by the Galileo spacecraft back in the 90s, completely rewrote what we thought was possible for moons. So, how does it do it? The leading theory is similar to Earth's. Scientists believe that deep beneath Ganymede's icy shell, there's a liquid, metallic core, likely a mix of iron and sulfur, that's convecting. This motion of conductive material generates electrical currents, and those currents create a magnetic field. It sounds simple enough, but the reality is far more complex and fascinating. Ganymede isn't just a solitary world. It's locked in a gravitational dance with Jupiter, the most massive planet in our solar system. This is where things get really interesting. Ganymede's magnetic field doesn't exist in a vacuum. It's embedded within Jupiter's own magnetic field, which is an absolute monster nearly 20,000 times stronger than Earth's. This creates a unique and complex interaction, a magnetic bubble within a much larger magnetic bubble. Imagine a small boat navigating a massive ocean storm. Ganymede's magnetosphere is constantly being battered, compressed, and twisted by Jupiter's immense magnetic influence. This interaction is a spectacular cosmic light show. Charged particles trapped in Jupiter's magnetic field are funneled towards Ganymede's poles, just like on Earth. This creates aurora, shimmering curtains of light, but with a twist, because Ganymede is also being showered by plasma from Jupiter's environment. Its auroras are a hybrid, influenced by both its own internal field and the external forces of its parent planet. The Hubble Space Telescope has actually captured images of these auroral footprints, showing us this incredible magnetic tug-of-war in action. They reveal how Ganymede's field lines connect with Jupiter's, a visible link between these two titanic worlds. But the existence of this magnetic field poses a huge puzzle. To maintain a liquid core that can generate a magnetic field, you need heat. Lots of it. Ganymede is incredibly far from the sun, so solar heating isn't the answer. The initial heat from its formation should have dissipated billions of years ago. So, where is the energy coming from? One major suspect is tidal heating. Ganymede is in an orbital resonance with two of Jupiter's other large moons, Europa and Io. This means their orbits are locked in a predictable repeating pattern. For every one orbit Ganymede makes, Europa makes 2, and Io makes 4. This constant gravitational push and pull from its neighboring moons stretches and squeezes Ganymede's interior, generating friction and therefore heat. This is the same process that drives the intense volcanism on Io. However, many models suggest that tidal heating alone shouldn't be enough to keep Ganymede's core molten today. It might have been enough in the past, but the moon should have cooled down by now. So, what's the missing ingredient? This is one of the biggest unanswered questions about Ganymede. Is there more radioactive material in its core than we expect, providing a slow, steady source of heat? Or is there some other, unknown physical process at play? The fact that Ganymede has a magnetic field, while its larger neighbor, Callisto, which is of similar size and composition, does not, only deepens the mystery. Perhaps the most exciting implication of Ganymede's magnetic field is what it tells us about its interior structure. The presence of the field strongly supports the idea that Ganymede is a differentiated body, meaning it has separated into layers: a metallic core, a rocky mantle, and a thick outer shell of ice. And this is where it gets even more tantalizing. Data suggests that sandwiched between layers of this ice shell, there could be a massive, global, saltwater ocean. In fact, this ocean might contain more water than all of Earth's oceans combined. The magnetic field acts as a protective shield for this potential ocean. Just like on Earth, a magnetic field can deflect harmful radiation, while the surface of Ganymede is blasted by radiation from Jupiter's magnetosphere. This internal field might offer a degree of protection for anything lurking in the water below. Could this subsurface ocean harbor life? It's a long shot, but the combination of water, a potential source of heat from the core, and a protective magnetic field makes Ganymede one of the most compelling places in the solar system to search for extraterrestrial life. The magnetic field is a crucial piece of this puzzle, a signpost pointing to a dynamic and potentially habitable interior. To get the answers we desperately need, we're sending a new mission. The European Space Agency S-JUICE mission, that S-Jupiter ICY Moons Explorer, is on its way to the Jovian system right now. After making flybys of Europa and Callisto, its grand finale will be to enter orbit around Ganymede, making it the first spacecraft ever to orbit a moon other than our own. JUICE is equipped with a suite of instruments designed specifically to study Ganymede's magnetic field, its hidden ocean, and its icy shell in unprecedented detail. It will map the magnetic field with incredible precision, helping us understand how it's generated and how it interacts with Jupiter. It will use radar to probe beneath the ice, searching for the definitive evidence of that global ocean. The data from JUICE will be revolutionary. It could finally solve the riddle of Ganymede's internal heat source, and explain why it, and it alone, is the Moon King with its own magnetic crown. It will help us understand the potential for habitability in these icy worlds that exist so far from the warmth of a star. Ganymede isn't just a big moon. It's a celestial laboratory, a world of extremes that challenges our understanding of how planets and moons work. It's a reminder that our solar system is filled with wonders that are still waiting to be discovered and understood. The story of Ganymede's magnetic field is far from over. In fact, we're just getting to the most exciting chapter. What do you think is keeping Ganymede's core hot? Let me know your theories down in the comments. And if you enjoyed this journey to the outer solar system, don't forget to hit that like button and subscribe for more deep dives into the cosmos. Thanks for watching, and as always, keep looking up.